3.1 Using the First Derivative. Southwestern College, Professor Maria Olivas. Using the first derivative. Objectives. Define when a function is increasing or decreasing on an interval. Analyze the first derivative to determine intervals on which a function is increasing or decreasing and locations of relative extrema. 1. Increasing, decreasing functions. Definition of increasing, decreasing. I'm going to begin by drawing a function. So I'm going to draw a function. I'm not going to draw the coordinate plane that it's on. I'm just going to go ahead and draw the function. Starting from left to right, I'm going to begin by drawing my function so that it is increasing. So here you're going to see me drawing a curve that is increasing. It's going to reach a peak and then it's going to start decreasing here. And then right here, I'm going to reach the lowest point and then I'm going to start going up. But instead of a curve, I'm going to draw a linear section of this function. And then I'm going to draw a constant function going all the way to the right to finish off this function. And we're going to label this as f of x. I'm going to write f of x in the upper right-hand corner of the screen. I have also drawn arrows at the ends of my function. So going all the way to the farthest point that I'm going to draw here, all the way to the left, but it's still on the right-hand side of the arrow that I drew here of my function, I'm going to label this with the x value of a. And then at the very peak, the highest point of my function, I'm going to draw a point there and I'm going to draw a dashed vertical line segment going down and I'm going to label that with the x value of b. And then at the lower point here of my function, I'm going to go ahead and label that with a point, call that c. And at the point where my function changes here from being an increasing linear function to a constant horizontal line function, I'm going to label that point as e. And the point that is going to be farthest to the right of this function, but still to the left of the arrow that I drew, that's going to be labeled as f. In between the interval from a to b, I'm going to draw two x value points here. I'm going to draw one labeled as x sub 1 and one labeled as x sub 2. And I'm going to highlight the region going from my left pointed arrow part of the function all the way up to where it's labeled as x equal to b. And I'm going to highlight that in yellow highlighter. This is going to represent the part of the function that is increasing. To define this part, we're going to say if x sub 1 is less than x sub 2 and f of x sub 1 is less than f of x sub 2, then this means that f of x is increasing. And that's going to be our definition for an increasing function here. I'm going to draw a vertical line segment right about underneath where b is located to separate my definition for an increasing function from the definition for a decreasing function. In the interval between b and c, I'm going to go ahead and also draw 2 points. But before I do that, I'm going to highlight in blue that interval from b to c. This interval is going to represent the part that is a decreasing function. So like I said, I'm going to label 2 points here. The first point is the point that's going to be closer to b. So it's going to be the point that's higher. So I've drawn a point and a vertical dashed line segment going down, and I've labeled that x value as x sub 1. And I have drawn another point farther to the left between x sub 1 and c, and I have drawn a dashed vertical line segment going down. I labeled that x coordinate with x sub 2. Underneath that interval, I'm writing down if x sub 1 is less than x sub 2 and f of x sub 1 is greater than f of x sub 2, then f of x is decreasing. I have drawn another vertical line segment to the right of what I just wrote to separate my definition for decreasing from the definition that I'm going to write on the right-hand side, which is going to represent the constant function. So I've gone ahead and I've highlighted in yellow the part from C to E that also represents an increasing function. And then I highlighted in green the interval from E to F. I've drawn in 2 points in that interval from E to F. I'm going to label the first point that I have here as x sub 1. I've drawn a vertical dashed line segment going down, and I've labeled that with an x sub 1 for the x sub 1 coordinate. And the second point that is in between x sub 1 and f, I've gone ahead and drawn a dashed vertical line segment going down, and I've labeled that x coordinate with x sub 2. In between x sub 1 and x sub 2, I've written that f of x sub 1 is equal to f of x sub 2. So for any x sub 1 and any x sub 2 that I choose between this interval from E to f, f of x sub 1 will always be equal to f of x sub 2. Underneath that interval, I am writing down a function is constant when it takes the same value for f of x no matter what x is. Over the interval from a to b, I'm going to write the word increasing, and I'm going to write f prime of x is greater than 0. And also over the interval from c to e, which I've also highlighted in yellow, I'm going to write f prime of x is greater than 0. So this represents our first derivative being positive. We can tell it's positive because here the function is increasing in these intervals. Over the region, or over the interval from B to C, where it's highlighted in blue, I'm going to write down the word decreasing, and I'm going to write f prime of x is less than 0. And over the region, or over the interval from E to F, the region that is highlighted in green, I'm going to write down the word constant, and I'm going to write down f prime of x equals 0. I'm going to circle the point where x is equal to b. I'm going to draw an arrow pointing at it, and I'm going to write down the words relative maximum. This point at x equal to b is going to represent a relative maximum. I'm going to draw a horizontal line that is tangent at that point, at that value where x is equal to b. I'm going to draw an arrow pointing at it, and I'm going to write down slope equals 0. Another way to represent that the slope is equal to 0 is by writing f prime of b equals 0. And I've drawn a little arrow pointing at the point from where I wrote f prime of b equals 0. I've also circled the point at x equal to c. I've drawn an arrow pointing at it. I'm going to write down underneath the words relative minimum that f prime of c does not exist. I abbreviated does not exist with DNE. That's because we have a sharp corner here occurring. We cannot take the derivative at x equal to c here. Theorem. Let f be a function that is continuous on the closed interval from a to b and differentiable on the open interval from a to b. 1. If f prime of x is greater than 0 for all x in the open interval from a to b, then f is increasing on the open interval from a to b. 2. If f prime of x is less than 0 for all x in the open interval from a to b, then f is decreasing on the open interval from a to b. 3. If f prime of x is equal to 0 for all x in the open interval from a to b, then f is constant on the closed interval from a to b. Definition. A critical value or critical number of a function f is any number c in the domain of f for which f prime of c equals 0 or f prime of c does not exist. So in order to find critical values, we're going to have to find the first derivative of f, and we are going to have to find those solutions when we set f prime of c equal to 0, or find where f prime of c does not exist. Picture. Let's go ahead and draw a picture here. Once again, this picture is going to look a lot like the picture I drew from earlier. From left to right, I'm going to start off by drawing increasing and then decreasing functions. So it's going to look kind of like a parabola for this first part. And then when it gets to the lower point here of the parabola, after I finish drawing the parabola part, I'm going to just draw a straight linear function going straight up so that we have a sharp corner at our lower point here. I'm going to draw a point at the highest point that we have here. And I'm going to draw a dashed vertical line coming down. I'm going to label that with the x value of b for that point. And at the lower point here, I'm going to draw a point and I'm going to label that with the x value of c. I'm going to go ahead and write to the left hand side of the function from b, alongside the function going upwards, I'm going to write f prime of x is greater than 0 because this is where our function is increasing. At x equal to b, I'm going to draw a horizontal tangent line, and above that I'm going to write f prime of b equals 0. To the right hand side of b, between b and c, I'm going to write alongside the function going downwards, f prime of x is less than 0. And to the right hand side of c, I'm going to write f prime of x is greater than 0 because the function is increasing to the right hand side of c. I've drawn a circle around c and I've drawn an arrow pointing at it, and I'm writing down f prime of c does not exist because we cannot take the derivative at x equal to c. I've circled b and c and I've drawn arrows pointing towards both of them, and underneath the arrows I wrote down the words critical numbers. B and C here in this picture represent critical numbers of this function, f. Theorem. The first derivative test. Let C be a critical number of a function f that is continuous on an open interval I containing C, if f is differentiable on the interval, except possibly at C, then f of c can be classified as follows. 1. If f prime of x changes from positive to negative at c, then f has a relative maximum at c. Above the word positive, I'm going to draw a little plus sign or positive sign, and I'm going to circle it. And above the word negative, I'm going to draw a little negative sign or minus sign and circle that. Number 2, if f prime of x changes from negative to positive at c, then f has a relative minimum at x equal to c. Above the word negative, I'm going to draw a little negative sign or minus sign and circle that. And I'm going to draw a little plus sign or a little positive sign and circle that above the word positive. Next to number 1, I'm going to draw a parabola opening downwards with a maximum at the very top. So I'm going to draw a point at the very top with an arrow pointing at it and write down max next to it. Next to number 2, I'm going to draw a parabola opening upwards, and I'm going to draw a minimum on that one. So I'm going to draw the point at the very bottom of that parabola, draw an arrow pointing at it, and write down min next to that one. In order to determine whether f prime of x is greater than or less than 0, first find the critical numbers. Then do a number line test. Example 1. Consider the function f of x equals 3x squared minus 4x minus 8. A. Find the critical value or values for f. Step 1. Find f prime of x. For step 1, we need to find the first derivative. And then after we find the first derivative, we're going to find the first derivative and then set it equal to 0 and solve that equation. Or another option would be to find where the first derivative does not exist. In this particular case, I can already tell here that f of x is a polynomial function. And when I take that derivative of that polynomial function, I will end up with another polynomial function. So this function is going to be continuous everywhere, and there isn't going to be any place where it does not exist. So we're just going to focus on setting the first derivative equal to 0. The first derivative is equal to 6x minus 4. We're going to take 6x minus 4 and set it equal to 0. I'm going to add 4 to both sides. We'll have 6x equals 4. I'm going to divide both sides of this equation by 6. And the 6's on the left-hand side of the equation will divide out, and we'll just be left with x equals 4/6 will reduce to the fraction 2/3. I'm going to put a cloud around that. This is going to represent our critical value. So I'm going to write down the words critical value underneath x equal to 2/3. Part B. Do a number line test to determine the interval or intervals on which the function is increasing, decreasing. Step 2. Number line test. I'm going to go ahead and draw a one-dimensional number line here, and at the center of my number line, I'm going to label that with the value 2/3. I'm going to draw a dashed vertical line segment right at x equals 2/3 to the left-hand side of my number line, right where the arrow is at. I'm going to write negative infinity. To the right-hand side, I'm going to write positive infinity, and I'm going to choose the values 0 in the open interval from negative infinity to 2/3, and I'm going to choose the value 1 from the interval from 2/3 to infinity. The 0 and the 1 are going to represent my test points. These are the values that I'm going to be plugging into my first derivative to see whether I get a positive value or a negative value. My first derivative function, if you recall, was f prime of x equals 6x minus 4. So we're going to begin by finding f prime of 0 equals 6 times 0 minus 4 equals 0 minus 4, which equals negative 4. Because I got a negative value, I'm going to go ahead and draw a negative sign above the interval where I had chosen 0. I'm going to draw a negative sign and I'm going to circle it. Underneath the negative sign and circle, but above the number line, I'm going to write down the word decreasing in that interval, on that open interval from negative infinity to 2/3. Now I'm going to find f prime of 1. F prime of 1 is equal to 6 times 1 minus 4, which equals 6 minus 4, which is equal to 2. Because this number is positive, I'm going to go ahead and write a positive symbol above that interval from 2/3 to infinity, and I'm going to circle it, and I'm going to write down the word increasing right underneath the positive sign, but above the number line on that interval from 2/3 to infinity. I'm going to write down the word increasing because I know my function, my original function, is going to be increasing on that interval. I'm going to go ahead and draw a vertical line segment here to separate the work that I did here on the left from the work that I'm going to do on the right of this line segment. It is also very important to remember to label your number line with f prime, or the first derivative of f, so that we know that this number line test is associated with the first derivative test. Step 3. Write out conclusion. If f prime of x is less than 0, that means it's negative, then this means that f is decreasing. So I'm going to go ahead and write f is decreasing on the open interval from negative infinity to 2/3. I'm going to box in the part that says f is decreasing on the open interval from negative infinity to 2/3. This is part of my answer. Next, underneath that, I'm going to write down if f prime of x is greater than 0, that means to say it's positive, then this means that f is increasing. So for my answer, I'm going to write here f is increasing on the open interval from 2/3 to infinity, and I'm going to box that in. I'm going to highlight the 2/3 that I wrote on the number line, and I'm also going to highlight the signs, how the sign switched on these intervals. So I highlighted the negative sign and the positive sign. Because there was a sign switch from these two intervals, that means that this 2/3 represents a minimum because the function went from decreasing to increasing. I'm going to draw something that looks like a parabola, and I'm going to draw a point at the bottom where the vertex should be going, and I'm going to draw an arrow pointing at that, and I'm going to write down the word min next to it to represent that this is a relative minimum. C. Determine the location, ordered pair of any maximums or minimums. So as I already started mentioning here that this x equal to 2/3 is going to represent our minimum, we're going to go ahead and write that down. C. Determine the location, ordered pair of any maximums or minimums. F of x equals 3x squared minus 4x minus 8. If I substitute 2/3 into f of x, I will find the y-coordinate of my ordered pair for that minimum. So I am going to find f of 2/3. This is going to be equal to 3 times 2/3 squared minus 4 times 2/3 minus 8. F of 2/3 is going to be equal to 3/1 times 4/9 minus 4/1 times 2/3 minus 8. F of 2/3 is going to be equal to 12/9 minus 8/3 minus, and I'm going to write 8 here. I'm going to need to get a common denominator, so I'm actually going to have to write that 8 so that I have a 1 underneath, but I'll do that in the next step. F of 2/3 is going to be equal to, I'm going to reduce the 12/9 to 4/3 minus 8/3 minus, so in the above step I wrote 8/1 and I multiplied by 3 to the numerator and denominator, so that's going to give me the fraction 24/3. So I'm going to subtract here at the end of this 24/3. F of 2/3 is going to be equal to, we're going to get a negative 28/3. This is my y-coordinate. This can also be written as negative 9 1/3, and this is also equal to negative 9.3 with a repeating bar over the 3. I'm going to draw a vertical line segment to separate the work that I did here on the left-hand side from what I'm going to write down on the right-hand side of this vertical line segment. I'm going to write down f prime changes from negative to positive. There is a relative minimum at x equal to 2/3. So the point, or the ordered pair where this relative minimum is going to be located at, is going to be 2/3, comma, -28/3. I'm going to go ahead and box this in. I'm going to box in the part that says there is a relative minimum at x equals to 2/3, and the point is located at 2/3, comma, -28/3.